Hello, welcome to Geothermal Energy Prospect Evaluation class. This is an introduction. For this course, this will be presented in English and in Indonesian as the introductory languages. The course description and the learning competencies for this course is, hopefully by the end of this course, you are able to analyze the integrated 3G data, which is used to assess and evaluate the geothermal potential in the prospected area. And second, hopefully by the end of this course, you will be able to understand the process of all geothermal exploration projects, whether it's from the production side or from the maintaining sites, or even from the latest technology and the utilization for geothermal energy. Throughout this course, you will learn and you will do such tasks such as reviewing the geothermal concepts, utilizations, 3G data integrations, evaluating potential geothermal energy, environmental issues analysis, and you will learn about the economical aspect of geothermal development. To start off, I would like to update you on the geothermal potential released by the government by the Ministry of Energy and Mineral Resources in 2020 from their One Map website. As you can see here, the geothermal potential is widely spread throughout Indonesia in almost all the archipelagos, from Sumatra, Java, Nusa Tenggara and Bali, Sulawesi, Kalimantan, Maluku, and even in Papua. Here we have an unleashed abundance of geothermal potential, which some of the resources say that we have up to 30 gigabytes of energy that has not been exploited yet. Project planning is very crucial. However, project planning does not only consist of the engineering and from the science aspect, but you must also consider the environmental aspect and the economical aspect. So therefore, knowledge on project management will also be important as for you to help assess and evaluate the longevity of a geothermal project. Here we have a timeline for geothermal projects, starting from the surface survey up to plant operation. As a geoscientist, we all have a prominent role in all the phases. Not only we are important in the development phase and the exploration phase, we are very important in all the phases because geothermal is very related to nature and is closely related especially to geoscience aspects. Therefore, us as a geoscientist, whether we are geologists, geochemists, or geophysics, we all have important part in all the development phases. I will be using a lot of this diagram throughout this course. This diagram is an S-curve representing the cost and the risks that will happen or that will occur in the geothermal development. Usually, the capital cost will somehow increases almost at the end of the projects, and the risk will follow from high to low until the end of the course. A geothermal project, we will start off with the preliminary survey or reconnaissance studies. Preliminary survey consists of the geological studies, geochemical analysis, and geophysical investigations. It all starts from a literature study or even remote sensing from all the references that has been retrieved from the past years. And at the end of the survey, hopefully the output that you will put together is a form of geological map, conceptual model, energy potential speculation, and also a proposed drilling and production site. These aspects are very important to determine the successful rate of a geothermal project. For geological observations, we usually we take data from outcrops such as these outcrops, or even the surface deposits such as the travertine or the silica sinter. However, one of the most important key aspects in geological observation is determining the stratigraphy of the area, because stratigraphy is the key to unlock the subsurface condition, which can help you assess the characteristic of the reservoir. Therefore, by understanding the reservoir, you will be able to understand the geothermal condition in the area, and you will be then able to determine what kind of exploitation you must do to follow. Following the geological observation, you have the geochemical analysis, which usually comprise of water and gas analysis. From there, we can determine the location of the manifestations and also the distribution of the manifestation, as well as the temperature of the subsurface using a geothermometer method. To complete the survey, we usually finish it off with the geophysical investigations. Here we have a data or a map or a model of a geophysical data acquisition from the resistivity and gravity investigations of an area. With the help of geophysical investigation, we then can deduce what happens or what is the condition of the subsurface. Then, after all the investigation, we combine all the geological, geochemical, and the geophysical data and we build a conceptual model, where usually the conceptual model should depict the location of the rock units, where the faults are, and where the fluid flow paths are. This is very important because the location of the rock units will determine the reservoir characteristic, whether it's a permeable or a porosity reservoir. The faults will determine where to tap or to drill. And lastly, the fluid flow paths will determine whether the system is actually a sustainable system or not. These three aspects can be deduced from all the 3D data that you have obtained in the previous phase. Following that, the resource potential can be estimated based on the speculative, hypothetical, and reserve. After some careful review, we will then determine whether the system has a high enthalpy or a low enthalpy. The differences in enthalpy can actually be very important in determining whether a system is used as a direct use or indirect use. Indirect use is closely related to a power plant, where direct use is likely to be related to tourism and other more local usage. Based on the conceptual model that we retrieve, the temperature data is not sufficient. We need more to elaborate on how the characteristic of a geothermal reservoir is. The reservoir modeling is usually done in the second phase, which is to confirm what is the condition and the real condition of the subsurface from or in a geothermal system. Reservoir modeling itself will help you determine and simplify the version of a real condition by eliminating the unnecessary components and giving the features that is deemed to be important, such as the lithologies and the faults and also the fluid paths. Here we calibrate what happens in the field and the computer model to obtain the real condition of the subsurface. From preliminary drilling, we can obtain corings data, such as the alterations data, the temperature data, and also the stored heat calculation. Because from the drilling data, we can obtain the heat capacity of a rock and also the volumetric heat capacity, which can only be done if you obtain a subsurface data. Here, then we can determine how much the energy can be produced from a well. From stored heat calculation, we can determine the net capacity that a geothermal well can produce. Therefore, stored heat calculation is a very important step to determine how much energy can be extracted from a system. Just from a simple conceptual model, you can then determine the drilling targets. Drilling targets is quite similar to petroleum drilling. However, there are several different methods and mechanisms that you must consider when you are doing geothermal drillings. However, it is quite the same, just similar like to the petroleum drilling. Here, from a geothermal system, when we're trying to drill, we are trying to target the fault. Why? Because the fault here serve as the opening or the fluid path. So then we can extract the hot water and also the hot steam, then for us to produce electricity. When we are completing a geothermal project, we can not only consider the scientific and the engineering aspect, we also have to consider the environmental aspects. The environmental issues reflects not only on the environmental itself, however, it also affects the economics, the local community, the regulations, and the practicality. In Indonesia, the environmental effects and aspects are regulated in the government law in the form of AMDAL. Here, the users must follow the regulation and consents for geothermal projects, especially in the environmental aspects. Not only that, the government also regulates some of the operational and the exploitation process. Other national standards that follow, such as the SNI and also the Undang-Undang 21 tahun 2014 about panas bumi. Later on the course, you will learn how to estimate the cost of a geothermal project. All we know, there is a capex and opex to support a project. It is quite the same in geothermal project. However, in considering the cost that is very high for geothermal projects, we must also consider the LCOE, or levelized capital cost for electricity. The number of LCOE is very important to determine how much cost of a geothermal project and how many years will it take for the project to actually reach its breaking even point or finalize its buyback. Usually, the lifespan and the buyback time ranges about 25 to 30 years, considering the inflations and also the LCOE cost of each countries. For cost estimation of a geothermal project, it is very important for you to have a prior knowledge on economical aspects. I hope this introduction will give you a glimpse on what we will learn throughout the semester. I will see you in the next course. Thank you very much for your attention.